In our day-to-day life, we come across a number of objects. Some of them are hot and some are cold. List some objects which are used in daily life and classify them into hot and cold. The experiments conducted by Count Rumford and James Prescott in the beginning of the 19th century established that heat is a form of energy known as thermal energy. Take 3 bowls on the table. Mark A, B, and C on them. Put ice-cold water in bowl A, ordinary tap water, neither hot nor cold, in bowl B, and hot water in bowl C. Put your right hand in bowl A containing cold water and left hand in bowl C containing hot water. Keep these for about 2-3 minutes. Then take out both hands and simultaneously put in bowl B containing tap water. Your right hand, which was previously put in cold water, will feel hot. The left hand, which was previously put in hot water, will feel cold, although temperature of tap water is the same for both hands. Thus, we conclude that heat is an agent which produces the sensation of warmth in us.
Measurement of temperature. A reliable measurement of hotness or coldness of a body is called its temperature. To measure temperature, a device called thermometer is used.
Take some hot water in a beaker or a mug. Dip the thermometer in water. Wait till the mercury thread becomes steady and note the temperature. Now take out the thermometer from water. Observe carefully what happens now. Do you notice that as soon as you take the thermometer out of water, the level of mercury begins to fall? This means that the temperature must be red while the thermometer is still in water. Clinical thermometer is used by doctors to measure the temperature of the human body. Thermometric liquid used in the thermometer is mercury. Clinical thermometer is used in degree Fahrenheit and degree Celsius scales. In the Fahrenheit thermometer, the markings are from 90 degree Fahrenheit to 110 degree Fahrenheit. The normal temperature of human body is 98.6 degree Fahrenheit. Each mark on the Fahrenheit thermometer is divided into 10 small equal parts. That is, one small division can be read as 0.1 degree Fahrenheit. In Celsius thermometer, markings are in Celsius scale from 35 degrees Celsius to 42 degrees Celsius. Doctors place the bulb of the thermometer in a patient's mouth. The mercury level of the thermometer rises to show the body temperature. Thus, doctors say the patient is suffering from fever. Take some tap water in a beaker. Dip the thermometer in water so that the bulb is immersed in water but does not touch the bottom or the sides of the container. Hold the thermometer vertically. Observe the movement of mercury in the thermometer. You will observe that the mercury will shift slightly up and down till the mercury thread becomes steady.
Precautions while handling a thermometer. Precautions to be followed while using a thermometer. Handle it carefully as it can break easily. Remember, mercury is toxic and should not be swallowed. Always wash the thermometer before and after use. Always make sure that the mercury in the thermometer is below the normal mark before use. Read the temperature by keeping the thermometer at the eye level. Do not hold the thermometer by the bulb. Laboratory thermometer. It is used in the laboratory and has a range of -10 degrees Celsius to 110 degrees Celsius. The bulb is filled with mercury or alcohol. The advantage of using alcohol over mercury is that alcohol is cheaper, less harmful, and can measure much lower temperatures than mercury. Precautions while handling a laboratory thermometer. While taking temperature with the laboratory thermometer, follow the same precautions as those of a clinical thermometer. The bulb of the laboratory thermometer should be always kept straight. Laboratory thermometers are generally more sensitive to temperature change. Hence, they instantly rises and drops on increase and decrease in temperature. That's why we cannot use it for measuring body temperature, because as it is taken out of the mouth, there should not be a drop in temperature, and thus it will give wrong reading of the temperature. The clinical thermometer comes with a king which solves this problem of sudden drop in temperature.
Here we will learn about transmission of heat. Take a metal rod and hold it with hand. Heat one end of the rod with the help of burner. Heat is transmitted from one end to the other as shown here. Take a copper rod and fix iron nails at equal distance on this rod with the help of molten wax. Fix this in stand as shown here. Heat the rod on a burner. After some time, you will see that nails are falling down one by one, starting from the free end. This confirms that heat travels in solids in the form of conduction, that is, heat transfers from one point at higher temperature to another point at a lower temperature without actual movement of particles. Repeat the same activity with the glass rod. In that case, the nails will start falling after a very long time. Thus, we infer from this activity that metals are good conductors while glass is a bad conductor of heat. Take a convection tube. It consists of a rectangular glass tube, ABCD, provided with a funnel. Fill the tube with water and clamp it in an iron stand. Drop a single crystal of potassium permanganate through the funnel. Heat the tube at point C. It is seen that the violet color of potassium permanganate starts moving towards A. It finally reaches the point D through B and C. The experiment proves that the particles of a liquid actually move towards source of heat and on absorbing heat energy move away from it. When the liquid at the point C absorbs heat energy, its volume increases and hence its density decreases. Thus, the lighter liquid rises up and creates a region of low pressure. To compensate this low pressure, the heavier or colder liquid from the side B flows to C. Thus, convection current is set up. Light a candle and place it under the chimney B. Now, hold a smoldering agarbatti near the mouth of chimney A. It is seen that smoke is sucked in by the chimney A. It then travels towards the lighted candle and finally rises up from the chimney B. The air in the region of the lighted candle becomes hot. Thus, its volume increases while its density decreases. This lighter air rises up through chimney B, makes a region of low pressure. To make up for this fall in pressure, the air from outside rushes into the box through chimney A. In doing so, it sweeps the smoke of agarbatti along with it. This smoke, moving along the air, marks the path taken by the air. Thus, we can see that the molecules of air actually move to the source of heat, and on absorbing heat energy, move away from it. Hence, gases are heated by convection.
To show the transfer of heat via convection, take a glass beaker half filled with water. Add a few crystals of potassium permanganate. Heat this over a flame. You will observe that the water at the bottom is colored, but is clear at the top. As the water gets heated, you will see columns of colored liquid rising up in the beaker. This happens because the water molecules at the bottom get heated and rise and carry energy with them. Transfer of heat by the movement of molecules from hotter to colder region occurs through convection. Applications of convection in daily life. We can observe convection in our day-to-day life. Land breeze and sea breeze are one of the applications of convection. They are caused due to convection of heat. During the daytime, land heats up faster than water. The air above the land also gets heated and rises. Sea water is cool. The air above the sea water is also cool and rushes to take the place left by hot air. Hence, cool breeze flows from the sea towards the land, which is called as sea breeze. During the night-time, the land cools down faster, and the sea water is still warm. The warm air above the sea rises. Cool air from above the land rushes to take its place. Thus, a cool breeze blows from the land towards the sea, which is called as land breeze.
To prove that heat radiation can travel in vacuum, take a flat-bottomed flask. In the mouth of the flask, fix a rubber stopper having 2 holes. Pass a thermometer through one hole and a glass tube with stopper through the other hole. Remove air from the flask by connecting it to a vacuum pump. Record the temperature from the thermometer. Place the flask in bright sunlight or in front of an electric heater. It is observed that thermometer records a rise in temperature. Thus, the experiment proves that transference of heat by radiation requires no medium. Take 2 identical thermometers and blacken the bulb of one of them with black shoe polish. Suspend them from an iron stand as shown here. Record the temperature of each thermometer. Now, place the iron stand in bright sunlight or in front of an electric heater for 5 minutes. It is observed that the thermometer with blackened bulb records higher temperature, 50 degrees Celsius, than the other thermometer. Greenhouse is made of glass sheets. Sunlight falls on the greenhouse. Some radiation reflects and some are absorbed by the clouds, earth and air. Air inside the greenhouse absorbs the sun's thermal radiations, so it becomes warmer inside. Warm bodies inside radiate thermal energy. These radiations are not transmitted by ordinary glass. Thus, these radiations during daytime are entrapped and cannot leave the greenhouse. Due to this, the temperature inside the greenhouse rises to a value which is most suitable for plant growth. Another application of radiation in daily life is tea or coffee stays hot for a long time in a shiny pot than in a blackened pot. This is because the shiny pot is a poor radiator of heat. You know that in summer we prefer light-colored clothes because light-colored clothes reflect most of the heat. In winter, we usually wear dark-colored clothes because dark surfaces absorb more heat. Let us explain this by an activity. Take two identical tin cans. Paint the outer surface of one can with black color and the other with white color. Pour equal amounts of water in each and leave them for an hour. Note the initial reading of thermometer of both the cans. Leave both the cans in sunlight for a few hours. Note the reading of thermometer of both the cans. You will observe that temperature of dark can is higher than the light colored can. Therefore, dark surfaces absorb more heat. Similarly, we feel comfortable with dark colored clothes in winter. Light colored clothes reflect most of the heat that falls on them, and therefore we feel more comfortable wearing them in summer. In the winter, we use woolen clothes. Wool is a poor conductor of heat. Moreover, there is air trapped in between the wool fibers. This air prevents the flow of heat from our body to the cold surroundings. So, we feel warm.